What you say, Mason? Say something.
Literally say anything. Yeah, it makes it
Mm-hmm. Thank you. Don't trip, please. Thank you.
I don't see how people drink black coffee.
Teach for 13 years. All right, let's start. Oh, it's been recording. Okay, let's start over here. Shh, I'm ready. I'm serious now. All right. So once again, it's the limit as x approaches a of f of x equals to L. That's how you read that. Now, sometimes you have some additional notation. You see that little negative sign, that little positive sign? If you see that, that means you're only looking at one side. Like you're looking at, as x approaches this, that means you're only looking at the left side of the function. Negative means left, positive means right. Does that make sense? If you do not see that symbol there, guys, like let's say I just saw x approaches 2. That automatically lets you know you got to look at both sides, okay? For example, let's say I had this. As x approaches negative 1, I'm going to look from what side here? Left. What does that mean I'm going to look at?
Right.
That means I got to look at what? Both. And guys, when you look at both sides, it's got to equal the same value. If it does not equal the same value, that means you do not have a limit, okay? Remember, the limit is the value it's approaching, okay? That's going to make more sense as we go on. It says the left limit may or may not be the same as the right. We talked about that. Okay. You remember back when we studied functions first unit. If I asked you to find f of 5, you went to 5 on the x and went up and find where it's at. F of 5. Okay. That's different from a limit because you can locate that. Just remember that and a limit might be different because a limit is the value it's approaching, okay? And it's going to make more sense, I promise, when we start seeing a problem. It says the limit is what the function should be. F of x is what it is, okay? And I'm going to show you that in a minute. All right, so let's look at this right here. Okay, come on. Okay, let's say we have some number a right here. And it says the limit is, let's say it together, x approaches what? A of h of x. Okay, so I got a right here. Did I have that positive or negative sign anywhere?
No.
And remember, it's going to be after the number, okay? No, so that means you got to look from left to right. So this is the left side of the function, isn't it? This is the right side, isn't it? So as I come along this function, what y value is it approaching? 1. When I come from the right, it's approaching what? 1. So your limit would be 1. Now, if I would have asked you what f of a was equal, what would you put? What's there at that spot? Open dots. That means it's what? Undefined. That's what I'm talking about right here in the statement. The limit is what the function should be, but f of x is what it is. See, it's not going to be the same thing sometimes. You see that? The limit is the value it's approaching. F of something is what it is. Does that make sense? Okay. Let's look at B. The limit as x approaches B. Okay, let's do it. Do I have that plus or negative after the B?
Yeah.
That means I got to look at both sides, don't I? Here I go. From the left side, I'm approaching some number 0.75. You see that? Now I come on this side. It's approaching something different, isn't it? In a limit, in order to have a limit, they got to approach the same value. So what would you put right here? Does not exist or undefined, whatever way you want to put. All right, we're going to come back from the table. We're going to look at these graphs because I want to make sure it makes sense. So our learning target today is I can determine the limit of function from a table or a graph, okay? So we're looking at graphs. Tomorrow we'll do it when we don't have any pictures, okay? That's what we'll spend a few days on. Now let's look here. What is f of 2? Now, this is not a limit. I just want to know what f of 2 is. What's f of 2 equal to in that problem? 4. Very good. F of 2. I went to 2, went up, it's 4. Now, as x approaches 2, do I have that plus or minus after it? No, so that means I can look at both sides, okay? Alright, from the left, as I come on from the left, it's approaching what value? From the right, it's approaching 4. So, what's your limit? 4. So, sometimes those equal the same value, sometimes they do not. Look at B. F of 3. What is F of 3? Undefined. There's a hole there. What type of discontinuity is there when there's a hole? Is it jump, infinite, or removable?
Removable.
Very good. You need to know that. That is removable. There's a problem occurring there. Now, let's talk about the limit. Remember, the limit is the value it's approaching. So, from the left, it's approaching what value? 4. From the right, it's approaching. So your limit's 4. So your see how that can be different there? Okay. You like this better in ellipses? Did I dismiss you or did you just get up?
Oh, I'm leaving for the team council.
Did you dismiss yourself? You may go. I'm just giving you a hard time. Go. All right. But I had a good example, so you're going to stand at the door so if I finish C right here, okay? All right. F of 1. What is F of 1 equal to in this problem? 1. You would not do the open dot. You would do the closed dot. You see that? Now, let's do the limit as x approaches 1. I got to look from the left and right. Here we go. From the left x values, it's approaching what? From the right side, it's approaching 2. So your answer is 2. Does that make sense? Have a great day. Take Mason with you. That was a don't get too excited. Yes, Ivy.
I really just don't understand like how you're doing this.
Which one did you don't understand? The top one or bottom one?
All of them.
Okay, you do know the top one because I've already taught you that this year.
Yes, the f of x. I understand
Okay.
how to get f of x. It's just the limit.
Okay, limit. Okay, as the limit as x approaches 1, you got to look from the left side and the right side the x values. So the left side of this, the left side, the x value is this way, isn't it? So if I go here, it's coming up the graph, and you got to see what y value is it approaching? 2. From the right side, the greater numbers on the right side, as you come up, you're approaching that value 2. Okay? We're about to do some more. Turn to page 10 in your notebook for just a second.
So it doesn't matter if, that point itself doesn't exist.
Yes, it is. All right. Yes. Okay. Page 10. Let's look at this graph right here. Now, Ivy, I'm going to go slow on this one, okay? Page 9. All right. So let's look at this beautiful graph. I want you to look at A. It says the limit as x approaches 1. What does that symbol mean? It does not mean negative 1, does it? As x approaches 1 from the left. Okay, so I find 1 right here. Left of 1 is this way, isn't it? So I start writing this graph till I get to 1. What value is it approaching on 1? The y value? 3. So your answer is 3 there. Yes, it would be. Now, the next part, does that mean positive 1 or 1 from the right? Okay, as I start on this function coming from the right, it's approaching 3. Those are called one-sided limits because you only look at one side. Does that make sense? Okay. Now, C says x approaching 1. So do you have to look at both sides? But didn't you just do that in these first two problems? If these are the same, what's your answer going to be? How about those two are different? What would be your answer here? Does not exist. Do you see that? Okay, D. As x approaches what? -5. Do I need to look at both sides? Yes, so -5's right here. From the left, it's approaching what? From the right, it's approaching. So what's your answer here? Does undefined or does not exist? I put does not exist. Let's put does not exist. Alright, how about E? As x approaches what? 5. What do you think about that one? Does not exist. Do number 12 right now. That makes more sense, huh? On A, does that mean -2 or 2 from the left? 2 from the left, okay? Don't say -2, that's not what that means. Okay, approaches 2 from the left. What is that approaching? What is it? 2, very good. 2 from the right. 2. What would be your overall two-sided limit then? 2, because they're both the same, aren't they? So 2, 2, 2. D. As x approaches what? -4. Do I need to look at one side or both sides?
Both sides.
What value is it? What y value is it approaching? 0. Very good. C. As x approaches 5, what y value is it approaching? -1. Are we good on that? Okay. I love looking at the graphs. All right, so the first learning target we talked about today is I can determine the limit from a graph. I need a hand signal. We're good? Okay. Now, let's go back to number 1 through 4, and then we're going to let you work on your homework. We're going to use the table feature. Use the table feature of your calculator. Now, guys, you got to estimate on this, so I'm going to be a little leeway on the right answer because you don't have to use your estimation skills, okay? So if your neighbor says 0.6 and I say 0.7, I'm going to give it to you, yes, because this is estimation. All right, so everybody needs a graphing calculator. And no, you just don't need to sit there and watch me. Everybody needs a graphing calculator.
So if there's not a break in the graph, then there won't be any undefined points like on the limit.
We're gonna talk about that in just a minute. Okay. All right. So it says use the table feature of your calculator. All right. So here we go. Make sure that your calculator is in the right mode. Make sure it is in function, not polar. Go to mode. Make sure FUNC is flashing. Now, I'm going to tell you, 5x cubed, does that mean any discontinuity in that? No, because that's going to be a perfect looking function. So let's type in 5x cubed. Alright, now I'm going to teach you how to set up your table here. Right above window, do you see TBL set? That means set your table. So I'm going to go hit second that. Never change the independent and dependent. It's always auto. Don't change that. I'm changing table start. And what do you think this means? Oh, first of all, table start means where do you want your table to start when you pull your table up, okay? That's what that means. I always put, what is x approaching here? 2. I want to know what's going on at 2, so I always put that number first. Now, what do you think this symbol means?
I think that's how it counts by. Yeah.
Very good. That means delta. And what does delta mean in math and science? Change. That means how do you want the numbers changed? You need to look at very small. So I always put 0.1. That means it's going to go up like 5.1, 5.2, 5.3, because I want to know what is it approaching when it's getting to that number. Does that make sense? Sometimes you might have to put 0.01, okay? So that's just up to your discretion. Now I'm going to hit second table. Second table. And I look at that. What's occurring at 2? What number is it?
40.
There's a set number there, isn't it? So what number is it approaching? 40. If there's a number there next to a number that you're dealing with, then that is your answer, okay? Yes, son.
How do I turn off the chi-squared class?
What now?
How do I turn off the chi-squared class?
Teacher, students, can I have your attention, please? Please excuse the interruption. I need in this time all of the new, only the new teen council members to make their way to the rotunda. All new teen council members, please make your way to the rotunda at this time.
All right. Now, let's look at number 2. I want you to look at the structure on 2. I just want you to don't say anything. I just want you to look at the structure. Okay? Because I'm going to ask you a question in a minute. I'm going to go back to y equals, and I'm going to type that in. X minus 1 divided by x squared minus 1. Now I'm going to type it in. I'm going to hit second table set. What number am I worried about approaching? Once I'm going to put 1 there. I'm going to hit second table. When I do that, guys, you see arrow at 1, don't you? That means it's discontinuous at that point. We got some discontinuity going on. Now my question to you is this. What type of discontinuity is it? Is it jump? Is it jump? I'm not going to yell at you to get it wrong. Is it jump? No, because why? Jump is only deals with what type of function? Piecewise. Is this a piecewise? No. My next question, is it removable or infinite? Why is it removable? Very good. Because could I factor that and cancel it out? I could remove something, couldn't I? You need to know those types of discontinuity. That is removable. Does everybody understand that? Okay, now, this is where you use your estimation skills. I'm looking at both the left and right side here of 1. 0.9 is going 0.52, 1.1 is 0.47. So what's a good estimate for this? It's approaching what? 0.5. I'll put 0.5. If you put 0.49, I'm going to count it right, okay? Does that make sense? Okay. I want you to look at the structure of number 3. The structure of number 3. Okay? Let's type in your calculator. When you type it, make sure you put the numerator in parentheses divided by the denominator in parentheses. We're just not going to do right. I'm going to go to second table set. What value am I worried about? 9. So I'm going to start it there. Hit second table. When I do that, guys, I see the word arrow at 9. So that means that there's some type of discontinuity there. Is it jump? No, because it's not piecewise. Would you say that's removable or infinite? Infinite. Could I cancel anything out? No. And what does infinite mean? There's a what at that point? Asymptote. Very good. There's an asymptote of some sort. If it's removable, that means there's a hole, isn't it? Okay. There you go. All right. So what's a good? Okay. From the left, it's approaching 5.98. From the right, 6.01. I would say it's approaching what value? 6. That would be good. Now in your homework, I should have done better with your homework. It's like stuff like 0.22 or 0.23. Just go out to the 100 spot on the homework. On your test, you would clearly see that. All right, last one. Y equals sine of x.
Just in degrees or radians?
Just degrees. Ooh. Might be a spill out there. Somebody did something. Alright, I'm going to go table set. I'm worried about as x approaches what? Okay, let's make sure we know how to read this. If I was to ask you to read that problem off your paper, how would you read it, class? Well, we're going to be here for a while. How would you read number 4? I want you to no. I want you to say it in unison. The limit of
Sine of x divided by x.
That's beautiful. Beautiful. Mason didn't participate, so we're doing another one. Let's look at number 3. Read it.
The limit of x approaches 9.
Okay, stop. He was moving his lips but not saying anything. Let's do another one. Go. Number 2. Never mind. Go on. Let's just. All right. Someone should start that at 0. His second table. Okay. From the left and right, it's 0.99. On the left side is 0.99. What would be a good estimate? It's approaching what? 1? Wouldn't you say 1? Okay, thank you. Are y'all good on that? Yes.
So the only ones that are going to have like an undefined answer will be piecewise radians.
Not necessarily. We're going to study those later, okay? All right. I want you... Make sure your calculator is in. It should be in degree. Mine's in radian. That's all right. We're not going to stress on that problem. I'm sorry. You're not going to have one like that. Okay. But yeah, it should be in degree. Mine was in radian. All right. Your homework is 1 through 5 is by table. 9 and 11 is by graph. Do 9 and 11 first. Do 9 and 11 first. On page 9. Like what I'm talking about on number 1, is it like 0.22? I got point, like it's very close. Like on number 1, it's like I would have said like 0.16 or 0.2, whatever you put on that. Yes, somebody said my name. Yes.
Number 3 has like a 50 number difference.
So then what I would do is instead of putting 0.1, I would go in there and put 0.01 to see what happens.
So it's supposed to be in degrees.
Number 1. So I would put either 0.16 or you put 0.2 all day you want to put. If you put it in your calculator and get something that's got a wide difference, then go back in there for your delta table and put 0.01 or 0.001 to see what you can see. Yes. You look at both sides. It doesn't have. So from the right, it's going here. From the left, it's going there. There's 2 different. It does not exist. Yes. You like that, thank you.
It really helps me.
Because when I was a student at school, I wish somebody would have done that. So I made notes of things I was not going to do as a teacher. You appreciate